All right, so welcome. My name is Stefan Sosnowski from the Technical University of Munich, and in the project, we are responsible for collecting the trash from the seafloor. So now we just heard from Lucian that in the project we found the trash, we know where it is on the map, so now we need to go there and actually pick it up. And as we just heard, when we send our robot, which is here for SEACLEAR 1, a standard robot with a gripper attached below, the localization can be off by a bit more than a meter. So if we have something small like the bottle here, how do we actually pick it up? Because we can be off by 1 meter, 1.7 meter. So since we have this mismatch here, we go here, we think the bottle is here, but it's actually here. How do we solve that? So we found a strategy for that, which means that if the bottle is not there where we assume it is, we know that it should be close. So the easiest thing is you just start spiraling around and searching for it again. Because we also have a camera pointing downwards, looking for the object again. And we can use the same detection that we just heard from the AI network, that we can find the object again. And if we find it, we see it in the camera image here. Unfortunately, the contrast is not good enough that you can actually see the image with the marked litter. But we now know again where the litter is. And since pose estimation itself can be again very crude, what we do now is use a simple trick by just doing it like a human would do. We see the object in the image, so all we have to do is bring the object to the center of the image. We move the robot so that we actually center on it, and then we know if we go down, we actually will have it in the gripper, and then we can grasp it. So this was for the first project, and we also have a video here showing, if it plays, the actual pickup from the demo in Dubrovnik. So we see the robot here with our gripper going down, centering on this bottle that you see laying on the sand. And once it's centered, it goes down towards picking it up. We measure the altitude to the seafloor through the DVL. And by that we have the exact height from which to start the pickup. And then we can carry it on to the collection basket. Now let me see how I can go back to the presentation. Okay, what we saw, this is a very small system and we can only pick up very small litter. So for the new project, we built a much bigger system, and this is this smart heavy lift grapple, as we call it. We can see it here and we can look at it in a bit more detail. So for the specifications in the project, we said now we want to really scale up and have big and heavy objects. That means we want to pick up objects that here can be about 1 meter by 1 meter, and especially with a payload of up to 250 kilogram of lifting force, which covers quite a substantial portion of litter that you can actually find in the ocean. We see here this new grapple is attached to the SeaCat on the frame, as we just heard from Yves, and we can use this also with a winch for lifting then the trash from the seafloor. So why do we call it smart heavy lift grapple and not just a grapple? Because it actually packs quite a lot of functionality in the grapple itself. So we have 8 thrusters here, these motors for omnidirectional motion, because same as with the ROV before, we want to center on the trash and actually have fine-grained motion and not just the big pendulum motions from the boat. So with this, we need to be able to move the grapple itself. We also have the full computation necessary for, again, detection and all the computation for the grasping on board. So this is a self-contained system. We have in total 8 joints, so 4 fingers with 2 joints each that we can move to adapt to more complex shapes of debris. Because you can basically find anything out there, so we need to adapt to any possible shape. And this flexibility helps us a lot with this. And what's special for this grapple is that we also have torque sensors in each joint. So what does that mean? We can directly measure the force that our fingers are producing on the objects. And we'll see in a minute why this actually matters. On the sensing side, we also have a Doppler velocity log for the velocity and the maneuvering down there. But we also have a stereo camera for capturing 3D images of what we see on the seafloor. And again, I'll also explain in a second why this is relevant. We also have 2 lifting magnets for any ferromagnetic stuff that we can pick up, that we can switch on and off on demand. Okay, so why do we need this extra sensing? Because from the object detection, from recognizing the trash, and a 3D reconstruction of the seafloor that we get from the stereo camera, we actually get a 3D representation of the object that we want to grasp. And this is important because with that 3D information, we now can have more clever strategies on how to actually grasp it. So we can calculate grasping points where we want to touch the object. But since this is kind of a bit tricky to do sometimes, the torque monitoring actually helps here as well. Why? Because if we're inspired by how humans do it, we can actually grasp things like this mouse here without even looking. Or, okay, now I didn't get the mouse, so that was maybe a bad example, but I got something, I felt that there is some. So I can touch the mouse and I can still grab it without having visual confirmation. Why? Because I feel the force and the contact with the object, and we do the same with our grapple, and this is why the torque monitoring, again, is important, so that we make contact, but we don't necessarily also destroy the object.